finding truth table of a given statement. So here in this regard we are going to find out the truth table of the given statement. So here we are going to deal this topic under the advanced level. So in this regard, a statement will be given to us, then we have to find out the truth table of that particular given statement. And now here the example is of, we have to find out, that is find the truth table of the statement which is P implies Q or negation of the negation P by implies Q. So we have to show the truth values of this given statement in the truth table, that is P implies Q or negation of this complete bracket, that is negation P by implies Q. Then now the solution starts. So in our solution, so here as per the problem, the statement which is given to us is of P implies Q or negation of negation P by implies Q. Then now we are going to show this statement, that is P implies Q or negation of negation P by implies Q by means of a truth table, by showing the given statement by means of a truth table. So here the truth table is of whereas here this is the truth table of the given statement, that is nothing but P implies Q or negation of negation P by implies Q. Then now here we have to show this P implies Q or negation of that negation P by implies Q by means of this truth table. Then now here, in order to show this by means of the truth table, so we need two statements. Let the two statements be, one is of P, the other is of Q. So here I am considering the two statements as one as P, the other as Q. Whereas in order to find out the truth table of this particular, so here we need P implies Q and as well as the negation P also. Then now first of all, on the LHS side here we need P implies Q. So here I want to find out first of all, that is P implies Q. Then after finding this bracket, first bracket, that is P implies Q, I need even the negation of that P. So here negation of P. Then after finding negation P, I have to find out the negation P by implies Q. Then now here negation P by implies Q. Then now for this bracket I have to find out the overall negation, the negation of this complete bracket. Then now here negation of this complete one, that is negation P by implies Q. Then after finding the right hand side and as well as the left hand side as the third column and the right hand side as the sixth column, then in the seventh column I have to find out the totally. On the whole it is of P implies Q or negation of negation P by implies Q. Then now here let us denote by means of the columns. So here this is our first column, the second one, this is the third column, this is the fourth one, this is the sixth one, and this is the last column as the seventh one. Then now, so here I have assumed two statements. When we assume a single statement may be either true or false, but here we have assumed two statements. So here there are four possibilities. So here both may be true, that is the truth value of P, if it is of true, then the truth value of Q also may be true. Then now both may be false also. So here I have assumed both as false. If one is of true, if P is of true, then the Q may be false. If the P is of false, then now Q may be true. These are the four possibilities of the statements, or these are the four truth values, or the four possibilities of the two statements, that is P and as well as Q. But here we need P implies Q. So here in order to find out P implies Q, the statement true statement does not imply the false statement. That means, so if the P statement is of true, then statement Q is of false, then now that implies is of false, TF is F, that is P implies Q. A true statement does not imply the false statement. So here true a statement does not imply the false statement mean. So statement P must be of true and the statement Q must be of false, then the P implies Q will be of false. So here let us find out. So here P implies Q. So we have to see first of all in column number 1 and then later in column number 2. So there must be of T and F. So here it is of TT. So here this is of second row, it is of T and F. So here when P is of T and Q is of F, P is of T and Q is of F, then the P implies Q will be of F. So TF will be of F and the remaining will be of true. Because there is no other way. So here it is of T and T. So it is of F and T and it is of F and F. We need only the statement P must be of true and the statement Q must be of false. When only the P implies Q will be of false. Then now let us find out the negation of that particular statement, that is P. So here P is of true, then the negation of P in the first row. So if the statement P, if it is of true, then the negation is of not true. If it is of not true, then automatically it will be of false. Then the negation of true is of false and the negation of the true will be of false. Then the negation of false will be of true and the negation of false also will be of true. Then after finding the negation of P, then now we have to find out negation P by implies Q. So here in case of by implies, so if negation P is of fourth column, we have to see under fourth column, and Q is of the second column, we have to see only fourth and as well as the second column in order to find out negation P by implies Q. But here negation P by implies Q mean if both the statements are of true, then we will be getting it as true, or if both are false, then also we will be getting it as true. So this is the condition for the by implication. So here both the statements, that is negation P must be of true and Q also must be of true, then the negation P by implies Q will be of true. So similarly if both are of false, then also the by implication will be of true. Then now let us search for T and T and as well as F and F in case of only negation P, that is the fourth column, Q as the second column. So we have to search under fourth column and second column. So here we have to search for TT and FF. So TT is not there, so here FF is there. When FF is there, so just by implication will be of true. So here it is of TT, then also it will be of T, whereas here is of FT, then the remaining will be of false. Then now we have to find out the negation of this complete bracket. The bracket is of negation P by implies Q. So it is of negation P by implies Q is the fifth column. We have to find out the negation of this fifth column. So here negation mean we have to find out the, so we have to attach not. So if the truth value of this fifth column first row is of false, then it is of not false to find out the negation. If it is of not false, automatically it will be of true. Therefore the negation of this false is of true and the negation of this true is of false and the negation of true is also of false and the negation of this false will be of true. Then later we have to find out P implies Q or negation of this complete bracket, that is negation P by implies Q. So P implies Q exists in the third column. Then now here negation of this bracket exists in the sixth column. So we have to observe third column and as well as the sixth column. So here P implies Q, third column, and the negation of this bracket is of sixth column. So here when we are observing third and the sixth column, so here between there is of R. So when it is of R, that is the disjunction. So here in case of disjunction, if first statement is of false, then the second statement is of false, then now the disjunction will be of the disjunction will be of false. Therefore F is F. We have to search F under the first statement and F under the second statement, under the third column and as well as the sixth column. So here F and F is F. Therefore here third column it is of T, then it is of T. So here we have to search only F and F. So here F and F is there, so it will be of F. Then now F and F is not there here. Here also it is not there, and the remaining all will be of true. So here true, true, and true. So from this it is clear that the truth table of this particular statement is of. So here we got T, F, T, and T.